Hello everyone, my name is Amparo Lopez and I am full professor in the Department of Environmental and Hydraulic Engineering at Universitat Politécnica de Valencia. Today we will be speaking about the part of hydraulic and transport model in terms of environmental aspects. So when we finish, we will be able to understand the nature of hydraulic and transport modelings in the engineering vision of the problem and to recognize the main part on the model and the aspects solved in any phase of this modeling situation. So we will be speaking of hydraulics and transport models in general, the parts of this sort of modeling, and these several parts, hydrodynamic, transport and kinetic model, and finally the conclusions. So hydraulic models are a model, a representing of the reality, and they represent hydraulic variables, pressure, velocities, in any times, flows, levels. They represent these variables by solving equations generally, because we are speaking about computational models, but they can also be physical models. In the terms of computational models, we can also introduce the concentrations of several pollutants, and then we have transport model. So if we also consider the kinetics of this transport inside or along the flow with biological and chemical interactions, then we have a full transport model. So the parts are three clear parts. The first part we have hydrodynamic conditions. In the second part we have transport aspects. And in the third part we have kinetics of chemical or biological aspects of modeling in terms of environmental. So let's go with each of these parts. Hydrodynamic modeling takes in condition boundary conditions spatio-temporal of the location of the problem, boundary conditions of velocity, flows, pressure, temperatures, and so, and solving the equation of the hydrodynamic model, which are normally related to Navier-Stokes equations, representing main movements inside fluids, we will have velocities and pressures. This is the output of this part of the model. With these velocities and pressures considered as an inlet, we will go to the transport model. The transport model will solve some equations representing the aspects of transport due to physical conditions inside the fluid movement. So the first thing we will have is convective transport. We will have transport because the fluid has velocity and it will transport with its velocity the pollutants. We will have diffusive transport. We will have transport because there is a difference in concentrations. So this difference in concentrations makes diffusion and pollutants go diffunded in the fluid because of this difference of concentration. And we will have turbulence transport as the fluid is chaotic. We have big Reynolds numbers and we have fluctuant components of velocity. We will have new values of concentrations. So this transport part of the model will give us some concentrations due to physical things. But then we will have to interact with chemical or biological kinetics in terms of non-conservative pollutants. So we will have to know the kinetics of these pollutants if they evolve in terms of chemical or biological or even other things, let's say nuclear aspects in the model, and then take again new concentrations. When we finish, we will have the final results for concentrations which can be used in any sort of fluids. Normally we use it in liquids, but it can be also used in gases, representing again the same parts. Hydrokinetics in terms of velocities and pressure, secondly transport, and then biological. So what we've learned in this moment is the nature of the hydraulic and transport model, indicating these main three parts: hydrodynamic, physical transport and chemical and biological kinetic solving, and taking them subsequently in order to get the inlet for the next step, and finally getting the concentrations of several pollutants due to any sort of problem that we want to model. I hope this was of your interest. Thank you very much indeed.